Good morning to one and all. Today we are going to discuss about the laws of set theory. The operations on set satisfying certain laws. The following are a few of these laws wherein A, B, C are subset of universal set U. In a sense, here we are going to explain, I am going to explain some of the laws in your set theory. So in this one, we refer it as a universal set and remaining all A, B, C. Fine. So first law we are going to discuss about first law. One is cumulative loss. It means this loss what it explains in the sense A union B is equal to B union A, or A intersection B is equal to B intersection A. In a sense, if you have A is equal to 1, 2, 3, if your B set is having a 4, 5, 6, at that time if you make A union B, you are getting 1, 2, 3, 4, 5, 6, or B union A, you are getting 1, 2, 3, 4, 5, 6, so that both are same. That's why cumulative law says that A union B is equal to B union A. Same that the second one, A intersection B is equal to B intersection A. So there is no difference. Here you consider A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6. So if you are making A intersection B, you are getting only 4. B intersection A, you are getting only 4. So if you are making A intersection B also the same output, if you are taking B intersection A also a same output. There is no difference in between those outputs. Fine. Associative law. If you consider associative law, so in this associative law, A union B union C, A union of B union C is equal to A union B of union C. It means that before if you combine B and C and later you combine this output to A, you are getting a same output. A union B, once you combine this two set first, then later if you combine with C elements, you are getting a same output. There is no difference. Like that, he tells that you just observed here. So this is the example. This is the theorem they proven. So instead of that, I am taking some values. A is equal to 1, 2, B is equal to 3, 4, C is equal to 5, 6. If you combined B union C, 3 to 6, you are making a group. 3, 4, 5, 6. Once you are combining A union this whole, you are combining 1, 2, 3, 4, 5, 6. You come here, A union B in the sense 1, 2, 3, 4. Union C in the sense, once again you are combining these values with these elements. So once again it is 1, 2, 3, 4, 5, 6. Like that, if you go for here, A intersection of B of C is equal to A intersection B whole intersection C. So if you making these two, you are getting a same output. Either LHS side is equal to RHS side. So if your value is like this, you can, if it is like this also, both are gives the same output. That one is says clearly. Come here, distributive laws. So if you consider a distributive laws, you just observed A intersection B union C is equal to A intersection B union A intersection C. It means that, so whatever the output comes from LHS, definitely it is equal to RHS. For that purpose, we have to take one example. A is equal to 1, 2, 3. Okay. B is equal to 4, 5. C is equal to, B is equal to 3, 4. C is equal to 5, 6. Just observe here properly. A is equal to 1, 2, 3. B is equal to 3, 4. C is equal to 5, 6. So if you are combining B union C, 3, 4, 5, 6, you got A intersection this whole. A is having 1, 2, 3. B union C is having 3, 4, 5, 6. A is having only 1, 2, 3. The same element is 3, only the same element in both A as well as B union C. So that's why output is 3. You come here, A is equal to 1, 2, 3. B is equal to 3, 4. So if we intersect here 3, union A intersection C. So if you done A intersection C, you are getting a null output. 3 union null is equal to 3. So you observed here the LHS is equal to RHS. If you go for distributive law, the same manner A union O B of intersection C is equal to A union B whole intersection A union C. This also gives the same values. If you want, you just observe here the same example I am taking, but values elements are different. A is equal to, I am taking here 1, 2. B is equal to 3, 4. C is equal to 4, 5. So you just do this one first. B is having 3, 4. C is having 4, 5. So B intersection C, in the sense you are getting only the value is 4. A is 1, 2. A union this whole means 1, 2, 4. You come here. Here A is equal to 1, 2. B is equal to 3, 4. A union B in the sense 1, 2, 3, 4. Intersection A union C. C is 1, 2, 4, 5. Right? So if you make this one, you are getting only 1, 2, 4. 5 is not present in both. That's why you are writing 1, 2, 4. Here also 1, 2, 4. Here also 1, 2, 4. So distributive laws says that A union whole B intersection C is equal to A union B intersection A union C. So independent laws. A union A is equal to A intersection A is equal to A. So if the set A is having a value of 1, 2, if we making 2 times 1, 2, 1, 2, that if you combine once again the same elements, you are getting 1, 2 only, not 1, 2, 1, 2, right? You are getting only once in 1, 2, that's it. If you done A intersection A, definitely the same element you are comparing with the same element. So definitely the values are comes same only. There is no different. So A intersection A is equal to A only, because this A also having 1, 2. This A also having 1, 2. So definitely if you compare this two set,